All right, so here we're going to talk about how to write the names of ionic compounds. And even though they're different than covalent compounds, I think they're even simpler. You just have to name what you see. Just like with covalent, we need to keep our elements in the same order as the formula. But unlike covalent, we're not going to have any prefixes in front of our names. We're just going to have the metal's name, that first element, then the non-metal's name, and then kind of like covalent, we're going to change that non-metal, that last element's name, to have that "-ide" ending. And because these are still non-metals here, then it's the same names that we've been changing to have that "-ide" ending previously. So there's no new names to work on changing and kind of getting familiar with. We're just going to have metal, non-metal, "-ide." We do not need prefixes in these ionic compound names because there is only one combination of sodium and oxygen that can form a stable ionic compound where the charges cancel out and add up to 0. And that ratio is Na2O. We get that by finding the symbols and the charges and cross-dropping reducing, like what we've been doing. So we don't need to say disodium oxide. We just name this sodium oxide, like what we've been seeing so far as we are writing those formulas. And then anyone can get those symbols and charges, cross-drop reduce to find this same formula. So just naming what we see. SrCl2. Sr is strontium. Cl is chlorine, which we're going to change to chloride. And that's the name. It doesn't matter that there's a 2 there. That has nothing to do with our name. Next, MgS. Mg is magnesium. S is sulfur, which changes to sulfide. And that's our name. Aln turns into aluminum nitride, because nitrogen, remember we just take that first syllable, so the nitra part, add "-ide" to the end of it. And then Ba3N2 is barium nitride. Same N at the end, doesn't matter that it has a 2 on it, it's still just nitride. We don't have any tris or dis here, just naming our elements that we see. It's almost like a little element quiz, just putting them together. K is potassium. P is phosphorus, which changes into phosphide. So names are pretty simple and straightforward. We just name what we see, change that ending to "-ide." Like I just mentioned, we had those element quizzes we gave you was to help you be more fluent, to make this easier for you. If you haven't gotten comfortable with these names and symbols, even though we don't have any more element quizzes to give you, you should still be practicing these. Finding them on the periodic table, sure, but also just practicing these names and their symbols so that you can be quicker at it, because our tests are timed. You're not going to get infinite time. And I can help you find some elements, but I can't help you with every single element and every single compound. So if you don't know your names and your symbols, you're going to take twice as long working out every problem, and you might only get halfway through that test. Even if you know how to do everything, if you don't know your names and your symbols, that's going to hold you back. So make sure you're still practicing with those if you need to. Now, just like we had lots of different variations, well, 3 different variations of our ionic compound formulas, we have these 3 different variations with our names as well. So our transition metals, remember, these elements have multiple charges. And so in the name of this compound, we need to tell the future person writing the future formula that's going to come from this what charge that specific transition metal has. So the most of the name is the same, like here with FeF3. If we didn't realize Fe is a transition metal, we would probably just start writing its names, naming what we see. Fe is iron, F is fluoride, or fluorine, which we would change to fluoride. And that is going to be 2 out of 3 points that you'd get on your test for naming this. But because iron is a transition metal, it does need a Roman numeral here, because iron could be a +1, a +2, a +3, a +4. It has lots of different charges that it can be. We need to figure out what charge it has in this specific compound and put that in the middle. And the way we figure that out is by looking at the formula. Like it says in our notes here, we're going to uncross our subscripts. These little numbers we've been putting down at the bottom when we were writing formulas. Remember, if we don't have a number, it's understood to be 1. That's the only number we don't write. we're going to uncross them. So bring them back up to the top where they started off when we were writing formulas, to turn them back into charges. And those charges that's going to tell us the charge of our iron atom, but we have to uncross both of them. I know you probably only want to uncross that 3 to find Fe, but we have to uncross both because Fe is only going to be a +3 charge if F is a -1. And it is. So because it is a +3 charge on that iron, this is iron 3 fluoride. But uncrossing doesn't always work, or it doesn't always go smoothly necessarily. If we look at this next example where I have my MnS, none of these have any numbers on them, so it's assumed to be 1, which would tell us that Mn has a +1 charge if and only if S has a -1 charge. But it doesn't. Sulfur, we know, has a -2 charge. Its charge is twice as much as these little subscripts make us think that it is. So if that one is twice as much, then our manganese here is also going to need to be twice as big. So this is manganese 2 sulfide. So I'm putting that Roman numeral 2 in here. And the reason that that wasn't a 2 at the bottom was because when we crossed and dropped here, we brought the 2's over and down, and that became Mn2S2. But then we reduced them out so that it was just MnS. So if we're going to uncross, then you also have to be ready to maybe unreduce as well. Multiply both of them by the same number. And that's why we have to always double check when we uncross. We can't just uncross the number that's going to go on to our metal. We have to uncross the non-metal too to double check if uncrossing has worked or if we need to do any multiplying there. So we look at this next one. Our root name, the normal name without a Roman numeral for Pb and O together, would be lead oxide. But lead is a transition metal, so we need to find its charge. If we look at these subscripts here, try and uncross them, then the 2 would be coming up and over onto our oxygen, be a -2, and the O's 1, which has to be a 1 there, would be going to our lead. So lead is a +1 if and only if oxygen is a -2. And it is. So that is going to be lead 1 oxide. We've got another lead oxide over here in question number 4. It's still lead and oxygen, so its root name is still lead oxide. But if the formula is different, that means lead has to have a different charge here. It's not going to be lead 1 oxide. Here, if we try and uncross our subscripts, then that would tell us that our lead is a +2 if our oxygen is a -1. That 1 from here uncrossing over onto the O. But O is not a -1. It's a -2 charge. It's double what these subscripts would lead us to believe, which means that this one also has to be double. So lead is a +4 charge, and our Roman numeral for 4 is IV. I think I listed these out earlier in the last video, but this might be a good place to write down, since we're having to come up with these Roman numerals ourselves, to put in our names. Like I said, 1 is 1 line, 2 is 2 lines, 3 is 3 lines, and then we get to 4, which is weird. It is IV, which only makes sense when you remember that V is 5. So this is 1 before 5, and then 6 is 1 after 5, so VI. So when in doubt, write the normal name. Don't give up on these just because you know it needs a Roman numeral and you have no idea what the Roman numeral should be. 2 out of your 3 points comes from just writing the normal name. It's only 1 point here for realizing that we need a Roman numeral and getting it right. So these are all Roman numerals. These are in the transition metal section, so you shouldn't be surprised. And when in doubt, check that second element's number. Whatever number is there should be uncrossing to be the charge of our transition metal, And in both of these, it ends up working because in both of these, this 1 and then this 3, the chlorine is a -1 charge, phosphorus is a -3 charge. So those both worked. When in doubt, just look at that second element's number and uncross it. Use that as your Roman numeral. So this is copper 2 chloride and gold 1 phosphide. That is definitely the hardest part of this entire unit, is figuring out those Roman numerals. But it's not going to fail you if all you're bad at is finding Roman numerals. You got to be able to use them. If I give you those Roman numerals, you got to be able to use that, use that as the charge, and cross-drop reduce to get these formulas. That you should be able to do. But coming up with them, figuring out what that Roman numeral is tough. I know, and you can make it. You can pass this test and even get an A. Without knowing exactly, being confident with those Roman numerals. So the last chunk of notes that we've got here, how to write the names of our polyatomic ionic compounds. Remember that polyatomic meant many atoms. So all of these compounds here have 3 or more elements in them that are combining into this ionic compound. But our ionic compounds still are only going to have 2 names, a first name and a last name. So if we've got more than 2 elements, then we've got to have a special group of elements that shares a name. Remember, all of these are on the back of your periodic table. So when you notice that there's a lot of atoms there, don't freak out, think it's as hard, this is complicated. Just flip your periodic table over and find that group. Every other part of this naming process is the same. So I can see that NO3 is going to be a special group. It's going to have a special name. So the magnesium part, the Mg part, is just magnesium. Then I flip my periodic table over. I find that nitrate ion is NO3, and that's our full name, magnesium nitrate. Remember that these extra 2's and stuff on the outside of the parentheses don't go in our name at all. We just name what we see. And we don't even change anything to "ide." We need to have that "ate" or "ite" ending on that polyatomic to tell other people that this is a special group and not just plain old nitrogen in our compound. The only time this can get a little bit weird or complicated is when we don't have any parentheses. You might not know what your special group is. You know there is one here because we can't have like copper nitrogen oxide. We can't have 3 names here. So you might just check CUN. That elements have to be next to each other if they're in this special group together. CUN isn't on the back of the periodic table. That's not a special group. So then we check the other half of our formula. And just like we just saw, NO3 is nitrate. So the rest of this gets named normally. Cu is copper. And then the NO3 part is nitrate. And then just like we did in the last set, you write your normal name, then ask yourself, does this need a Roman numeral? Because of course, we can also have these Roman numerals, those transition metals, in with our polyatomics. And then copper is a polyatomic. This is a little bit harder. We can't uncross this quite as easily because this 3 didn't cross over onto our nitrate. That Cu, with whatever charge it had, was getting with nitrate, which had a -1 charge, but that 3 was part of the nitrate. So here, especially with polyatomics, I really like to use the fact that our ionic compounds add up to 0. The total charge in any ionic compound has to be 0. So if I know, and I'm kind of trying to draw a scale here, just to visualize the charges have to be equal and opposite, they have to be balanced. If I know nitrate is a -1, then this copper has to be a +1 for it to all add up to 0. With this next name that we need to write, our special group is in parentheses, so I just need to name my zinc normally. Look at the back of my periodic table, figure out that PO4 is phosphate, and just name what we see. Do I need a Roman numeral here? We actually don't. Zinc is a transition metal, but remember it's one of those 3 special ones. Zinc is always a +2. It never changes. It's one of those 3, aluminum, zinc, and silver, are the only ones we do not need Roman numerals on, even though they're in that special area where they are transition metals. So moving right along, naming what we see and finding our special groups. SO4 is going to be our special group here. So we name the first part normally, Ag is silver. SO4 is sulfate. Do we need a Roman numeral? No. Like I mentioned, silver, just like zinc, has a set charge. We don't need a Roman numeral. This next one has that same sulfate in it, so I'm ready to go. It's just this one is with lead. So this is lead. Sulfate. Do we need a Roman numeral for our lead? Yes. It's a transition metal. We don't know its charge. So if we think about this charge, and if I don't draw a big fancy scale, I usually just kind of break it up. Sulfate's charge is a -2, so in order to cancel that out, lead has to be a +2. This next one, I can see my fancy group right off the bat. Ammonium is that NH4, and we got nitrogen at the end of our compound. It's going to be nitride. Even when we've got that fancy polyatomic at the beginning, if we have a normal element at the end, no matter whether it's with, anytime we get a normal element at the end of our compound, it's going to change its name to have that "ide" ending. We never add "ate" or "ite." We only ever add "ide" if it's a normal element. So ammonium nitride is our final name in our notes. So hopefully this wasn't too bad. We do have some practice problems that if you weren't in class, I really would recommend that you at least get started on these. Maybe do the left-hand sides on your own so you can come in and check them, and then you'll have time to finish these out. So you don't have to come to class with these completely done. We will have some time next class period to practice them, to check them, but I've been telling people in class already, you will be graded. I'm going to stamp your packet. Your part of your grade next class is going to be finishing one or both of these pages. So if this is completely blank for you, I need you to try and start writing some of these names and formulas, at least trying it. Like I said before, write the left-hand side, come check them in class. If there's any issues, we'll talk about it, we'll make it better. Then you can finish the other half and have plenty of time. If you come with it completely blank, you're going to have to really buckle down, because it's not just going to be these practice problems we're doing some other stuff in class that's going to take up some of our time. So if you have questions, of course, reach out to me, let me know, come in for tutorials, I'll help you get caught up, and we can work through it together. You can just check your answers in tutorials. If they're good, you don't need me, we'll move on. But we are most of the way done with this unit. We've only got one other type of compound that we're going to learn how to write the names of. So we're practicing next class, then we'll do that other type, review, and we're going to be testing before you know it. So be proactive about catching up and understanding how to write these names and formulas for ionic and covalent compounds.